Hello and welcome everyone to the Carbohydrate Chronicles, a podcast about glycoscience and glycoscientists. In this show, via a series of interviews, we explore the world of carbohydrate science and innovation from a personal point of view. Your host today is Tamás Sohajda, a member of Carbohydrate scientific team. Designing novel sugars and understanding how they work is an extremely challenging task. Accordingly, carbohydrate chemistry and supramolecular carbohydrate chemistry requires devotion, persistence, and creativity. José Manuel Garcia Fernandez, professor at the University of Seville, is working on such challenging innovations and discoveries around the uses of novel sugars for innovative applications. José will guide us into the world of cyclodextrin and carbohydrate chemistry, unravel a few mysteries, and point out challenges and possibilities of the future from a chemistry point of view. Welcome, José. It's nice to have you on the show.
Thank you. Nice to meet you.
José is an author of almost 250 scientific publications and almost 24 industrial patents. Current targets of his laboratory work include the development of pharmacological chaperones for the treatment of protein-folding diseases, the design of self-assembled glycocarriers for drug and gene delivery, the investigation of the mechanisms at play in multivalent enzyme inhibition, and the implementation of new technologies for the preparation of prebiotic oligosaccharides. So it's a fairly wide interest, José. You can deal with all these topics simultaneously?
Well, I don't know if simultaneously, but yeah, you are right. It's a broad variety of topics, essentially anything that has to do with carbohydrates. Carbohydrates are important for health and also are important for nutrition and also for pleasure.
Tell us a little more about your background. You have been working in Seville for a long time. Are you originally from Seville?
Yes, I was born in Seville, indeed. And it is almost by hazard that I finished in Seville because I was at the point I was to stay in France. But then when I was trying for the second time, so I had the opportunity to apply in Spain, and the Institute of Chemical Research where I work was just founded, just created. So I was lucky enough to ensure a permanent position here in Seville. So I finished in my birth city.
It must be nice to come back to your roots. Speaking about roots, does science run in the family? What made you become a scientist?
Indeed, my father was a defense lawyer, so nothing to do with science.
Well, lawyers may argue with that.
But anyway, so my mother was a chemist. She teach in the secondary school. She managed to deal with a family of 6. So in a sense, there was a root for chemistry because, at that time, for a woman doing this academic pursuit, high education, it was not that common. So yeah, I followed the mother's tradition, let's say, in chemistry. I have to say that I decided to start chemistry in the very last minute when I have to take the decision about to which kind of studies pursued at the university. So I was considering humanities and science, everything. I was passionate by literature, Latin, or on the other side, physics, biology, biochemistry, or chemistry. So finally, I had a professor in my last year at the bachelor's instilled me the love for chemistry. So this very last day, I decided to write chemistry in the formula and do not regret.
I think the whole industry is lucky that you chose chemistry. And when you chose science and chemistry, were you already or at the very beginning devoted to organic chemistry and carbohydrates, or that just happened later?
No, it happened in the way I found, all matters interesting. In the third year or the first course of organic chemistry was delivered to the students, and I immediately thought that was the one. That was the discipline I would follow. I entered into the group, so-called Carbohydrate Fine Chemistry group, that was led by Professor Fuentes Mota. So that's how everything started. And there I had the chance to meet Carmen, who later became Professor Ortiz Mellet, and is my wife. So my love for organic chemistry solidified together with the personal part of my life.
You chose the carbohydrate chemistry before you met. So what made you choose the carbohydrates?
Well, indeed, my first contact with carbohydrate chemistry, that's funny, was when I was in the bachelor, because this professor that had influenced me to do the chemistry studies, so she was a very good one. He prepared some experiments in the laboratory in the high school. It was to do some experiments to confirm what we have learned on the textbook. And one of the reactions we have learned from the textbook was the Fehling reaction, reducing sugar.
Very typical one. Yeah.
Yeah. So I think this was kind of destiny, because it was the first contact with sugar chemistry. I remember just taking the juice of the grape and looking the changing color of the Fehling. And then at the end, so I entered this organic chemistry department that had a long tradition for carbohydrate chemistry, well, because one of the founders was a disciple of Emil Fischer, Francisco González Garcia. So he established a tradition of excellence in carbohydrate chemistry in Seville. Seville was a strong spot of carbohydrate chemistry in Spain, especially, and that continues indeed. So I wanted to be part of this.
After the studies or during your studies, you also took shorter and longer periods abroad. You went to Poland, France. Did you visit these labs to expand your knowledge, or what was the purpose?
Well, indeed, my first stay was in Warsaw, Polish Academy of Science, with Professor Marek Mielewski. And we were studying some reaction of sugar thioureas at the time. We were looking for compounds so-called antinocicetives, so compounds that abolish the sense of pain. And it was in 1988, so it was almost the end of the communist time in Poland, so the Jaruzelski time. And there was a kind of electricity in the street, with this solidarity movement led by the iconic Lech Wałęsa, who became the first democratic president of Poland just 2 years afterwards. So there was I remember it was very interesting, both scientifically, but also from the personal point of view. Can you imagine 20-something in Poland at those times?
Witnessing history, yeah.
Yes, history. And then, yeah, Grenoble was very important, was transformative in my scientific, professional, also personal life. Grenoble was for my postdoc. So I went to the laboratory of Professor Jacques Defay, who was a well-known carbohydrate chemist, especially in the cyclodextrin field. There we became close friends and also collaborators. So he played a very important role in my professional life, and he supported me in difficult times too. I moved with Carmen. I moved with family. Already two boys when I was there, so Pablo and José Manuel. And during being there, was a daughter coming, Carmen. So it was almost 5 years there. During being in Grenoble, one of the most gratifying things of being there for so many years was I met giants of carbohydrate chemistry there, like Christian Pedersen, very great chemistry from Copenhagen Technical University. I met Derek Horton, the editor of Advances in Carbohydrate Chemistry and Biochemistry from Ohio State University, or people like Stephen Angial from South Wales, though he was Hungarian, by the way.
Yes, I can recognize the name. Grenoble, it's not a surprise. Grenoble is still one of the hubs of carbohydrate science with a very active research.
Absolutely. We continue to have close contacts with the people in Grenoble, many colleagues there. Of course, they are also giants in carbohydrate chemistry now. So coming back to your point, yes, in 1995, I came to Spain for an opposition to the Spanish National Research Council. So in 1996, I joined the Institute for Chemical Research in Seville that was just created at that time. Was the first position assigned to this institute indeed. So I'm the oldest one in the institute. Coming back to Spain, I don't know if I think anyone that has been for a long time abroad will tell the same. Readapting to your country is not that easy. It's not that easy. Yes, you are used to a different system, accessing research project fundings or collaborations and so on. Even the philosophy and the way of doing research was quite different from France to Spain at that time. It was hard, I may say, to get to become an independent researcher after coming back to Spain, having my own laboratory space, entering the national research agency. Yeah, finally, the support of Jacques and Carmen was essential at the time, both in the moral point of view and also economically, by supporting part of the research we were doing together. And after that, I may say, once you are established, things are easier.
When thinking about your research, or when you plan or do research, what is it that you enjoy most in it? What is it that motivates you in the morning to start?
Yeah, that I have a clear answer. That's curiosity. I mean, for me, it's first curiosity, and during my professional journey, also strong motivation has been to contribute to the community in a way, in my case, to scientific community, of course, but to make an impact in society in general, to put a grain of sand at least for that. So this is the debate between fundamental and applied research. I think it's nonsense. I mean, of course, if you're in academia, fundamental research must be the cornerstone. But if you are as a fundamental researcher think that there will be another one coming after you that will take your results to develop an application, you are wrong. You can enter into collaboration. You can find a lot of fun by collaborating on that. And if you have the opportunity to collaborate with the private sector, that has to be something, you have to be proactive for that. And then that can be very gratifying. If you can develop a fundamental research led by curiosity, but then this result you have can serve to attack, to provide a solution to real world problems, that very much gratify.
When thinking about initiating a new research, you always look at the bigger picture and try to see it from the very beginning to a hopefully applicable end use, that you try to see the whole journey of a research from the benchtop to industrial applications.
There is a philosophy, yes, there's a general philosophy in the lab regarding the strategies or the approaches we undertake when we have a project to develop, we have an idea, and we always try to develop this idea using strategies and approaches that will eventually allow an application. For instance, if we try to use reactions that we think we will be able to scale up, let's say, for instance, under conditions that will be eventually, that you could eventually translate into industrial settings.
I think this is a mindset that's very much needed to drive science forward, and I really agree that doing research that has, well, essentially industrial interest in the first place, and it's also designed in a way that can be industrialized later, is certainly an advantage, and that's a unique mindset still. Were you never tempted to go to the private sector with this mindset?
I entered the academia. I never thought about going to the industry as a first option. But once in the academia, I have enjoyed very much collaborating with people in industry. I mean, in the same way I have met giants of chemistry in the academia, I have found incredible people in the industry. I have met real friends and people who will. I really enjoyed discussing chemistry, discussing research, and they were industrial people. However, our technology transfer office sometimes has tempted me to create a spin-off. I remember for this question, for example, for this topic of the prebiotic caramel, I mean, we may talk later on, but we developed a technology to create to fabricate a caramel that was enriched in prebiotic components. At that time, I remember that our technology transfer office saying, okay, now this is a really good project for a spin-off. This is low risk, high gain. We licensed the technology. Yeah, I found it too complicated to create a spin-off and to enter in a different world. And so finally I discarded this.
So you always resisted, never created a company on any of your inventions?
No, I never. I don't say no. I mean, but if I enter this world, I will enter with people that really know the floor.
You have a really open personality and very wide interests and seem to have the character that do not really like closing doors. Is that right?
Yeah, that's right. I have to say, I don't know if it is very good for for a scientist. I'm chaotic, I have to say. So we have a very good team, Carmen and me, because Carmen is very practical, and me, I'm very chaotic. And yeah, otherwise I will be probably lost. I remember in France, when I was in the lab, so my bench was a mess. I have, I don't know, 50 reactions turning at the same time. And once I decided, okay, that doesn't go. I have to clean up. I have to make some order and so on. I did. I spent 2 days, and then there was a colleague, a Polish colleague that was there, fellow, and he said, "Oh, what have you done? You have destroyed everything. There was a creative chaos."
With the support of an organized person, that can be a very nice harmony.
Absolutely.
I see that you really are passionate and that really like your work. Do you have any hobbies for the times when you're not in the lab?
Yeah, that's a difficult question indeed. I have hobbies, but I don't have the time to practice the hobbies. And it is very rare a day that I'm not devoting several hours in reading, writing, or analyzing data at home with the computer. Carmen also do, so that's why she's also guilty. Even that, yeah, I like trekking very much. So I try to force me, because I'm not very proud in being working all the time. We should do something different. So it's not something that I'm recommending to anyone. So I forced me to plan some trekking routes. And I also like classic music. So indeed, I tried to be musicians when I was a kid. See, my grandparents from father's side, they were both musicians. So they enrolled me in the music school. And I studied there polyphony, violin, several years of violin. And then, I realized that I was not very skilled for that. So I never became a violin player. And I rather prefer to play football. And at the end, I actually didn't finish to be a very good football player either. So I had to be scientist. Carmen sings in a couple of chorals. So I'm allowed to attend the performances. And
do you sing too?
No, certainly not.
Well, it's good to leave that to the real talented ones. I can completely understand how difficult it can be to disconnect from research, and I think the people who are really devoted and who really enjoy it feel very similarly a lot of times, because it's not a work, it's something that you truly do for joy and a greater purpose, and time just flies. Let's talk a little bit about the projects and scientific journey. So could you name, not one, because apparently it's impossible to name one, but a few of the most interesting carbohydrate discoveries that you have done in your lifetime?
Yeah, I can mention first this question that we are talking about, this prebiotic caramel. There was in my time in France, and so there was a big concern in the Western economy because this increase in the price of oil. They launched a national project. The idea was to replace petrochemistry with sucrose chemistry, because you can have everything from sucrose, and this is a renewable source. So I entered this project. The idea was to transform sucrose into other type of building blocks that were more stable and could be incorporated into polymers, liquid crystal, detergents, other type of materials. There was published a review article in Advances in Carbohydrate Chemistry and Biochemistry on caramel. And we were shocked because it was mentioned that caramel was in our diet, part of our diet for millennia, and nobody really knew what was inside caramel. By curiosity, I remember very well this evening when I with the lab, I went to the supermarket. I bought a liquid caramel bottle. I took in the morning, I acetylated the caramel, and I compare by mass spectrometry with my acetylated mixture of AHF sucrose product. And it was exactly the same pattern. It was crazy. So I was very much surprised. So the same compounds I was producing to make polymers, where we were eating this, and nobody knew that we were eating this type of compounds. And we characterized those compounds, and of course the point was those compounds were good for health, or we should be careful with this. We were seeing that this compound had prebiotic properties. They are metabolized by our microbiota. But of course, there's a lot of sugar remaining in normal caramel. Only 10% are those compounds. So then we developed a technology, coming back to Spain, to produce caramel having 70% of those materials, of those DFAs, of those healthy materials. And this prebiotic caramel have been used to feed chicken, pigs, and even an animal model of Crohn's disease. And it was seen that it was a very positive impact in this model to treat these inflammatory bowel diseases and so on. So there has been a very gratifying discovery during my professional journey at the very beginning.
How about pharmaceutical innovations? What are the most memorable ones on those fields?
Yeah, there are two, I may say, to that. One is compounds for the treatment of rare diseases. So this was indeed, originally was Carmen project, glycomimetics. So develop carbohydrate analogs that will be able to interfere in transmission of information on biological processes involving sugars. So these they are very particular glycomimetics. They are very unique. Unlike any other type of glycomimetic, they can participate in glycosylation reaction, which is the paradigmatic reaction of carbohydrates in nature and also in chemistry. So you can create oligosaccharide, glycoconjugates, and so on. And then you can really address many problems. And one of the problems we addressed was these rare diseases, so-called pharmacological chaperones. So there are diseases where the protein, there is an enzyme that doesn't fold properly and endoplasmic reticulum, and then it is destroyed by the quality control of the cell, and the protein cannot go to the final destination. And so a substrate will accumulate with fatal consequences normally. And so we create compounds that can refold this protein. And so trafficking is restored, and the protein goes to the right place, and the protein works. And we develop compounds to treat Gaucher disease, DM1 gangliosidosis, and also Fabry disease, for instance, also Pompe disease now. We met the patients, so we have a personal commitment with these people that are real heroes. So it's very difficult to get funds to do research in rare diseases because, of course, do not affect many people in the world. But they deserve to be treated as anyone. They have the same rights. And we continue to do. Now we have a collaboration with an American pharma, so-called Amicus Therapeutics, for the development of next generation pharmacological chaperone for rare diseases, particularly for Fabry disease. And then the second one I wanted to mention is for called gene delivery with cyclodextrins. Indeed, we started also in France, the concept of using cyclodextrin for delivery, of course. There we started to think about delivering biomolecules, not only small molecules. And the idea was to incorporate into a cyclodextrin as a platform that allows oriented functional groups in very precise direction, functional elements to complex nucleic acid to self-assemble, to form nanoparticles, and then to drive those nanoparticles to the biological fluids and so on, to the organs, and transfect the cells. So at the very beginning, I wasn't able to get funding because it was considered a crazy topic. I got very, very harsh comments. In 2013, I remember, the first time I proposed this project was refused. But then 2 years later, and it was founded, and I got good comments on this. And now with the COVID pandemic and so on, so the topic was in the spotlight. So now we are collaborating also with private companies and so on.
These innovations are really fascinating, and they're really moonshot ideas. Is getting funding the biggest challenge, in your opinion, for such ideas to become reality, or are there other technical or scientific walls that you need to break? What is the biggest challenge to progress these projects?
Yeah, in the case of the rare disease project, the main challenge is always the animal model and then a clinical trial, because the patients are very few in the world, and you need a register of those patients, and then to produce a sufficient amount of the drug candidate to conduct this clinical trial. So you need a company. You need a company that will collaborate with you and that will finance and take care of those issues. And regarding the nucleic acid delivery, there is so we have also a collaboration with industry, so that's okay. You always will need collaboration with industry to go to the end. But even to achieve this preclinical dossier to convince an industry, so there are some challenges. And there, in this particular topic, the challenge is to fight lipid nanoparticles, because with these vaccines, these vaccines based on lipid nanoparticles and messenger RNA has been very successful in fighting the SARS-CoV-2 pandemic. So they have demonstrated efficacy in millions of people. So developing a new technology, even if conceptually different, maybe better, would be very difficult because of that, because this is already proven for in many people. So it will be very difficult for a big company, very difficult also to convince investors that they will develop a new technology. There's this one that has been just developed and demonstrated efficacy. So for a new technology to proceed, it has absolutely to provide solutions to problems that these lipid nanoparticles still cannot solve. And a particular problem is stability of the vaccines. If our compounds are able to provide a solution to this stability problem, so that would be an opportunity. And there is also an opportunity if this molecularly based delivery system that on our hands they can do, is delivering high-size cargo, for instance, self-amplifying RNA, because lipid nanoparticles have also a limitation in the size of the cargo. You have also to consider that lipid nanoparticles have some unwanted or might be unwanted immune issues, exaggerated immune response, for instance, and depending on the application, if it is not for vaccine, but it is, let's say, for instance, for protein replacement, so you have to avoid immune stimulation.
Thanks for explaining these important point of views. I think they're really crucial. One last question, completely unrelated to science and research. If you could have dinner with a historical figure or celebrity, dead or alive, who would it be and why?
That's an interesting question. There is someone, let's say, that play a role, an important role, maybe in tipping the scale towards science in my professional journey when I was very young. And this is the French writer Jules Verne. I was fascinated at the time. I was an avid reader. I was surprised how this guy could imagine the rocket, for instance, and from the Earth to the Moon, and then describing the outer space, and then of a submarine and the deep sea with a detail that was unknown at the time, and with technologies that were not developed at that time. So to this imagination is enabled by science. And if I'm allowed to invite two more people to the table, I'll be very happy to invite also together Leonardo da Vinci and Marie Curie. Indeed, these three guys represent the qualities I think are important in our researchers. First is imagination. Second is curiosity. And then, of course, perseverance is also important, and resilience. And there, Marie Curie, I think, is a very nice example.
This four-way dinner sounds really fascinating. And I can completely understand your pick, because based on our conversation, I see that you share a lot of values with these people. I hope you enjoyed the most recent episode of Carbohydrate Chronicles today, delivered to you by Carbohydrate. We talked with José Manuel Garcia Fernandez, learned about, despite many achievements and a great career, it's important to remain humble and value our humanity and treat our fellows with kindness. As Jose says, we have to walk with open eyes and be proactive and collaborate, especially with the industry, and be ready to accept challenges when our instincts tell us so. You've talked a lot about very fascinating research projects, and I cannot wait to see how they evolve and how they find their way from the benchtop to real life applications. It was a real pleasure, Jose, and thank you for accepting the invitation again. Next week, in the next episode of Carbohydrate Chronicles, we'll talk with Milo Malanga, CSO of Carbohydrate, who also deals with cyclodextrin and carbohydrate chemistry like Jose, designing new molecules for innovative applications, mainly novel active ingredients and drug delivery systems. Your host was Tomas Shaheda from Carbohydrate. I hope you'll join me in our next episode too. See you in 1 week. Goodbye.